Hello, dear student friends. In today's lecture on taking out quantities by center line method and long wall short wall method, we are going to discuss about the detailed estimate of a load bearing structures. So in taking out quantities, we are going to study basically the two methods that are called as the centerline method and long wall short wall method. Now let us look at what are the contents given in unit number 2. So whereas in unit number 2 in part A detailed estimates, we have to study the detailed estimates of load bearing structure as well as reinforced concrete structures. So here we are going to study what are the factors to be considered while preparing detailed estimate. Whereas the concept of estimation of load bearing structure, that is there are two methods, one is a PWD and centerline method. Here please remember that PWD method, that is its long form is Public Works Department, and this method is nothing but a long wall and short wall method. So once we study how to take out quantities from a given drawing, that is plan, elevation and section, by using this plan, elevation and section, that means drawings are very useful for finding the quantities in different items of the works. So here in detail estimate, we are also going to study the estimate of RCC frame structures by using IS 1200. Now before studying the different methods of taking out quantities, we have to study the different intellectual skills. So what are the intellectual skills? That means there are certain objectives with which we are going to study this topic. So in intellectual skills, number 1, to understand the concept of centerline method of taking out quantities, to interpret the terms joints for calculating the total centerline length of all the walls, to understand the concept of long wall and short wall method and interpret the length of the long walls and short walls. Next one is a motor skills. So we know some intellectual skills are required, at the same time the students should exhibit the motor skills. That means after studying the basic concepts of long wall and short wall, students should be able to calculate the total quantities by long wall and short wall. That means number 1, ability to calculate total centerline length of all the walls of the building considering number of joints. Number 2, ability to calculate length of long walls and short walls. Number 3, ability to take off dimensions of the different atoms. Number 4, ability to prepare measurement sheet and find out quantities of different atoms. Now whenever we want to study or to find out the quantities for detailed estimate by using long wall and short wall method as well as centerline method, we will require some prior concepts. Some basic concepts should be studied before going to calculate the quantities. That means we must know or we must study the working drawings, plan, elevation and sections, detailed drawings. Then we have to study mode of measurement. Then there are certain new concepts we are going to study in this topic, that is centerline method for working out quantities, and second one is a long wall or short wall method. And then we are going to study how these all dimensions of the structure are entered in a sheet which is called as a measurement sheet. Now let us think about detail estimate. So detail estimates are prepared by carefully and separately calculating in detail the costs of various items of the work that constitute the whole project from the detailed drawing after the design has been finalized. The quantities for each atom may be estimated and shown in the pattern which is called bill of quantities. The unit in which each atom of the work is to be calculated should be according to the prevailing practice as followed in various departments of the country. Now this is a format of a bill of quantities. So whenever we observe different components different parts of a structure from elevation, section and detailed drawing. So as per the serial number of different atoms, we are going to write down serial number in first column. Second column we are going to write down brief description, then number of repeated atoms are written in number column, then in measurements length, breadth and height are noted down, and after that as per the type of atom the quantities are found out. If it is a volumetric quantity, then length, breadth and height are multiplied. If it is a quantity like a plaster or painting or flooring, then length and breadth will be multiplied. After that, we are going to calculate total quantities, and if there is any specific remarks regarding that particular atom of the work or construction activity, then that remark should be written in the last column. Similarly, this is another format which is called as abstract. It is also called as a priced bill of quantities. After finding out number of atoms or different atoms in a building work, next duty is to find out cost of that particular atoms. So see, in serial number, the same serial number is taken from measurement sheet, description atom is written, then unit of that atom is written, then total quantity from measurement sheet is copied here, and rate is copied here from our current DSR or SSR. DSR means district schedule rates, and whereas SSR means state schedule rates. Nowadays the PWD department is publishing the state schedule rates. So nowadays no district schedule rates are available. After that we can write down remarks in the last column. So let us study about the methods of detail estimate. So first method is unit quantity method. So in this method the whole project is subdivided into different items of work or activities. The quantity for each item is then calculated separately from the drawings as accurately as possible, and the procedure is known as taking out quantities. In the second method, that is total quantity method, here atom of work is divided into the following 5 categories. That is number 1 material, number 2 labor, 3 plant, number 4 overheads and number 5 profit. Now in case of taking out quantities, the important aspect of detail estimate is that whenever we want to find out or we want to calculate detail estimate, then a engineer or the estimator has to take a great care so that the margin between the actual cost and the estimated cost should not exceed 10% to 15%. So therefore accuracy of the estimated cost depends to a great extent upon the accuracy with which the quantities are taken out. Therefore, taking out quantities is a very important aspect in the process of detailed estimate. A great care has to be taken. Not only in arriving at the correct dimensions from the drawings, but also that no atom of work is overlooked. Now let us study what is meant by taking out quantities. Actually, the process by which the quantities of the various atoms in a particular structure are worked out is known as the taking out quantities. So there are general principles of taking out quantities. So what are the principles of taking out quantities? Let us study. That is number 1, study of drawing. So whenever we want to find out quantities of different atoms of work, we must study rigorously the drawings, so overall drawings, and attempt to visualize the work. Study drawings carefully, that plan, elevation and section and other details are in agreement with one another. Then check the dimension of drawing to make sure that each overall dimensions agrees with the total room dimensions. If error is there, then the drawing should be corrected. If dimensions do not exist in some places, then it is always better to write them in the drawing by working out from the other dimensions. Now second principle is the visit to the site of the work. So every engineer or estimator, whenever you want to calculate you want to do the estimate, detailed estimate, he must visit the proposed site so that he will know the characteristics of the site. Similarly, by visiting the site, he may collect information such as access to the site, nature of soil, and any other useful information for preparing a detailed estimate. So there are a number of items are there in construction activity of buildings. Let us consider a residential buildings, that is a load bearing structure or RCS structures. So number one item, first item will be excavation, number two will be foundation of concrete, number three foundation masonry, number four dam proof course, 5 number filling in plinth with hard muram, superstructure, that is brickwork or stone masonry, door, windows and cupboard frames, window sills and lintel over openings, roof, plastering and pointing, flooring, water supply and sanitary fittings, electrical works. Now let us look at one by one methods of calculation of the quantities, and that is number one is long wall and short wall method. So here a two-roomed building plan have been shown with the interior dimensions of rooms are 3 by 4 meter, and there is a common veranda to these two rooms which is 2 meter wide, whereas thickness of the walls above plinth level is 30 centimeter, and a stepped footing is shown, and in the cross section of a wall the width of PCC is shown, then steps of the foundation, that is 70, 50, 40 are marked, and the plinth level of this structure is 60 centimeter above the ground level. Now whenever we want to calculate the quantities of for example PCC or the foundation stage 1, stage 2, stage 3, or a quantity of brickwork, we have to follow the long wall and short wall. So in this plans, whatever plan we have seen, in this plan the foundation plan is marked. So first a center line is marked at the center of the foundation trench, and the width of foundation trench is plotted on both sides of the center line, and long walls are marked as well as short walls are marked. So from the sketch, the sketch is self-explanatory, indicating the long walls, which is the longest dimension, horizontal dimensions are long walls, and vertical wall in between the long walls are the short walls. Now when you look at the sectional elevation of a long wall, and you will observe that if 7.6 meter is the length of PCC, as we move from PCC, that is bottom of excavation, bottom level of excavation, to the plinth level, then it is observed from the sketch or elevation that the length of long wall decreases as we move from bottom of trench towards the plinth level. So therefore length of long wall is equal to center length between the short wall plus half into bracket width of the short wall at the extreme edges of the long wall at appropriate level. Now rule number 2. So here in this sectional elevation, here long walls are perpendicular to the figure plane, and the short walls are in between the long walls. So from the figure itself, or from the sectional elevation of the short wall itself, it is clearly understood, it is clearly seen that as we move from bottom of foundation towards plinth level, length of short wall go on increasing. So for example 3.6 meter is a first step length of the first step of the footing, length of the short wall, but as we move up to the second level, then it becomes 3.3, then it becomes 3.9, and then it becomes 4 meter. So that means the length of short wall increases as we move from bottom of the trench towards the plinth level, which is vice versa, opposite of the long wall measurement. Now let us look at the finding the quantities of one room building by both methods. So how we can apply same principles, that is two methods, long wall, short wall, as well as central line method. So in this diagram, again a single room a plan is shown whose internal dimensions are 4 by 5 meters and thickness of wall is 0.3 meter. All the dimensions of PCC, then first stage, second stage footing and plinth level as well as superstructure wall, all the dimensions, height and widths are mentioned in the section. So from this drawing, now look at this colorful drawing for a center line method. So for this room, first mark a center line, then after marking a center line, as we know the width of the excavation trench is equal to the width of the concrete provided in the footing. So we have marked a 0.45 meter distance on both sides of the center line, and thus if you observe that the two vertical walls and two horizontal walls, or two vertical center line lanes and two horizontal center line lanes are intersecting at corners, and a dark blue squares indicates that both walls are overlapping there, whereas plain white square indicates that there is no overlapping. That means we can directly add the center line distances 5.3 plus 5.3 plus 4.3 plus 4.3. In this way you can calculate total center line length, and after getting total center line length for a concrete, just you have to multiply this total center line length by the width of the concrete and multiply by again the thickness of the concrete. We will get total quantity of concrete in meter cube. Similar way we can find out same quantity of concrete we can find out by using another method, that is a long wall and short wall method. So in this case what they have done, that this is a plan of a PCC, and here horizontal walls are considered as a long wall, and in between this long wall short walls are there. So algebraically or arithmetically you can calculate add the total length of the wall together. So long walls 5.3 plus 0.9 will be the length of one long wall, and length of short wall will be the center to center distance 4.3 minus the thickness of one wall, that is 3.4. Therefore total quantity of concrete in foundation will be 2 into 6.2 into 0.9 into 0.3. as there are two long walls, therefore 2 into 6.2 into width of PCC into thickness of PCC, plus again there are two number of short walls, therefore 2 into 3.4 into 0.9 into 0.3 cubic. In this way we can calculate quantity of concrete by long wall and short wall. Similarly, if we want to find out the quantity of brickwork in a first step of a footing, similar principles are applicable in this case also. So again in this problem the center line method is used, and therefore total center line method total length of center line for first stage of footing will be 5.3 plus 5.3 plus 4.3 plus 4.3, that is 19.2. That means on around the periphery of this plan, whatever total center line lengths are marked there or shown there, they are added together and we will get total center line length, and this total center line length of a first stage of footing multiplied by width of that stage is 0.6 and multiplied by its height 0.3, we will get the total quantity of brickwork in first footing by center line method. Similarly, same first stage footing, that is the quantity of brickwork in first stage footing, can be found out by long wall and short wall. So again it is similar to the previous cases. Horizontal walls are long walls, whereas vertical wall in between the long walls are short walls. So finding individual lengths of long walls and short wall, add them together and then just multiply by their width and height, and adding them you will get total quantity of brickwork in a first stage of footing. Similarly, quantity of brickwork. So we have studied until now how to find out the quantity of PCC in footing, the quantity of first stage of footing. So here we are going to study in a similar manner, in a similar way, how to find out the quantity of brickwork in walls. So basic principle is same. Whatever we have studied in the previous case is same. Again, only the what is the basic change in this plan, that is only width is changing. So whenever you are at the bottom of foundation, so we have to consider, if you want to consider PCC, so width of PCC you have to consider and thickness of PCC. As we move up, so as we move up, the dimension of or width of the footing go on decreasing, and as we move towards the plinth level, the minimum thickness of wall will be there. Therefore here 0.3 meter is shown, and same way total centerline lengths are added. Now after adding total centerline length of a wall, its width and height is multiplied to the total length of the wall, we will get total quantity of brickwork in cubic meter. Similar is the principle, that is second method, long wall and short wall method. Again, long walls are horizontal walls, vertical walls in between them are short walls. Adding the length of all long walls and short walls together and then multiplying width and height of the walls, you will get total quantity of walls in cubic meter. Similar will be the principle applicable for a two-roomed building. So this is a plan of a two-roomed building, and in this again internal dimensions are 5 meter by 4 meter. So again section of a footing is shown separately to the right side. Now if you look at this colored centerline diagram, here all the periphery walls are not overlapping, and that means whenever we find out total centerline length of all the outside walls, we will add their centerline length together. But whenever we want to find out centerline length of intermediate crossing wall or intermediate wall, here the intermediate wall crossing with the horizontal walls is shown by a red parabolic sign. That means there is overlap. So that means these are called as T junctions. So here there are two T junctions, and that is the extra portion we are considering for calculation of the quantities of concrete, and therefore that extra portion of overlap of an intermediate wall should be deducted from the total centerline length of the structure. So therefore first find out total centerline by adding all centerline distances at the periphery as well as intermediate wall, and after getting this total centerline length, in this case 34.1, from this 34.1 from this 35.1, so you can calculate 34.1 into 0.9 is the width of the concrete into 0.3 is the thickness of concrete, that is total volume of concrete. But whatever parabolic marks, red marks are shown there for the overlap, that overlap should be subtracted. Therefore from the whole quantity of concrete in foundation, the overlap is subtracted, that is 2 into 0.9 into 0.9 by 2 into, and the thickness of concrete is 0.3. In this way we will get net concrete quantity of concrete in foundation. Similarly we can use same thing for the total quantity of concrete in foundation. So here this plan and sectional elevations are shown. If you want to find out a quantity of concrete in foundation by using a long wall and short wall method, so you can consider these horizontal walls as long walls, and these three intermediate vertical walls in between long walls are short walls. So adding all these walls together, multiplying their width, that is actually please remember here that the concept of long wall and short wall, that means it is not every time it means a wall. This is a concept, long wall, short wall. This concept can be applicable for excavation or for PCC or first stage of footing, second stage of footing, or plinth level, or the superstructure walls. Okay, so long wall and short wall always doesn't mean it's wall. It is a concept applicable for that level. In this way, here also total quantity of concrete in foundation can be found out by adding quantities of concrete for long wall erection as well as short wall erections. So that is the end of this lecture on methods of finding or taking quantities by using center line method and long wall short wall method. If there are any questions in your mind, you can ask without any hesitation. Thank you very much for listening the lecture patiently. Thank you once again.